Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. So, in this episode, we're going to begin to take a look at something called Gson. This is going to be super useful in serialization and deserialization, which is just saving and loading of levels. If you've ever used Unity, we will be implementing something similar to their level editor, where we will be able to declare components and we will be able to dynamically generate save data for those components as our game engine runs, and this is going to be super useful. So it's really cool and I'm looking forward to show you guys how to do it. So let's take a look at what Gson is and how we can use this to our advantage. It's always good to know exactly what problem you're trying to solve before you begin coding and trying to solve it. So what is the specific problem we're trying to solve? Well, that is serialization, or just saving and loading game data. This is literally just transforming some game object that looks like this with its components into some JSON format, some binary format, whatever format you want to use that makes it look like this, where it has the name and it has component 1 and that component has some properties X, Y, Z, so on and so forth. And you basically just turn it into some format that you can then read back in, deserialize, and turn it back into this game object that we have over here. Now, if any of you followed my Geometry Dash series, then you know how we did the traditional method, which was basically we have a base class called serialize, and this base class has a couple functions. It basically has a function that says serialize, and then each class creates its own static deserialize method, which basically just returns a game object from wherever the file is currently parsing at. We would have the base component class inherit serialize, and all of these classes would then inherit this serialize method, all the components. And then game object would also inherit from serialize. This is a huge pain in the butt, because what this means is now for every single component you create, you have to implement this serialize method, which is probably just a few lines of code anyways, but it's so annoying because you have to remember, okay, I have to make this in a nice way to serialize, which, I mean, you should be thinking about that generally, but it just is a pain in the butt because you can't just code. Every time you create a component, you have in the back of your head, how am I going to be able to make this easy to serialize? I would like to remove that. So this is the problem we're trying to solve, okay? Traditionally, we have to create a serialize method, which then calls into a bunch of functions that says like, okay, save int, the name is vel x, and we want to give it velocity .x. So that's, and then we would do that for the rest of the properties and everything that we want to save. Well, we want to eliminate this completely. We don't want to have to deal with this at all. So that brings me to our solution. Serialization using reflection. Reflection is basically a newer type of paradigm that's in some newer programming languages. Programming languages that are not C, basically is what I mean by that. So Java supports this, C# supports this, Python supports this, basically any language except for C and C++ and some older languages than that too. And all reflection does is allow us to say, hey, I have this player controller class. Hey, what are my fields in here? And then you can say, give me all the fields. Then this will give you, like, if this has some sort of speed variable, some float speed, and it will tell us, hey, we have a floating point variable here. Its name is speed, and its value currently is 0.5f. Reflection also allows us to say, at runtime, I would like to set this speed variable to 0.8f, or whatever value you want. So instead of actually coding it out and saying either like a set method or coding it out and turning this basically the initial value into something different, you can literally set up some sort of function that finds this speed variable, loads it from some data that we have in a text file, and then sets it implicitly. Okay? This is extremely powerful. Okay, this is so amazing and just opens up a world of opportunity. We are going to be using something called Gson, which implements this super well, makes it super easy for us to do this. We have to do a couple of custom deserializers and serializers just to help Gson in its way, because these guys are all pretty abstract, the component class, and we want to make sure that we always get it right. But Gson is basically a way for us to say, hey, I have some class, some type, some whatever, I want to serialize it. And then you can just say, hey, Gson dot to JSON, my object, and that's a horrible J. And then what this will return is a serialized JSON object. So it would be like my name of your game object, and then it would have all its properties and everything in JSON with this one call. Super awesome. Which, I mean, that's basically what we had in the past, but in the past we also had to implement all the serialized methods in here too. We don't have to do that anymore. It's completely gone, completely eliminated. So the system we will come up with will be very, very powerful, very, very helpful. And one of the reasons that I love these languages, because C++ does not support reflection. Okay, let's get into it. Let's explore Gson a little bit, see how it works, and get it imported into our engine. All right, guys, so I am here at Gson's repository. This is developed by Google too, and it is completely open source, which is just super awesome, because then if you want to implement this in a different language, you can take a look at how they did it. Now, let's take a look at how they say to download it. They have Gradle, they have Maven, they have jars. It's Google. I would hope they would have all that. So since I'm in Gradle, I'm just going to copy this line, and we are going to paste it into our project. So let's go into our settings.gradle file, or not settings.gradle, build.gradle. And then right above the I am GUI stuff, I'm going to say Gson and give it that implementation. And then I will import the changes. When IntelliJ asks me to import those changes, we should be good. I'm going to pull up that build window real quick just so that we can be sure. And this should build perfectly fine. All right, we're good. So that's all working correctly. Let's actually implement a little Gson thing just to see how it works. So we'll play around with it a little bit first, and then we'll implement it for real. So let's go into our level editor scene. Our goal right now is going to be to serialize an entire game object. We'll see if we can get to that by the end of the video, and if not, that's fine. We will be continuing this in a second part anyways. So let's say Gson. The way we can build this Gson object is through this thing called new Gson builder. And this will allow us to set a bunch of different settings. So I'm going to do it like this because this is how they did it, and it looks kind of nice. We'll say set pretty printing to true. And then if you have other objects that you want to do too, then you can do that. .create. Don't forget that .create, because that is important. Now that we have our Gson object, let's just see how it works. Let's say JSON.toJSON, and I'm going to give it just the number 1. So we will print this out to see what happens. Let's print it. This is one of the examples they give too, just so you can get started. And we get 1. That's pretty cool. Let's print out a string. Let's print out hello world. See what this does. Do we get the quotations or not? And we get quotations, hello world. So that's cool. That's telling us this is sort of creating a Gson object out of this. Now, one of the important things to note with Gson is you cannot have a constructor that takes in variables. So we will have to change quite a few things, because right now our constructors take in variables. This is not how Gson works. So what we're going to do is we're going to work on sprite renderer first. Let's comment this out and modify it so that it does not take a constructor. Instead, we want the default color to be a new vector4f. 1, 1, 1, 1, and we want the default sprite to be a new sprite that we will also make constructorless. Okay, so we're going to make that constructorless also. And the last transform, I am going to set to transient, and is dirty, I'm going to set to transient. So basically, Gson is able to look through private and public member variables, so it will be able to find all of these. And that's good. That's what we want. But if you add in this keyword transient, it basically is a flag that tells Gson, hey, these are variables we do not want to serialize. And it will ignore these. It will look for these ones. It will ignore these ones. Okay? Let's go into Sprite now. Let's fix this up and do it so that it does not take in any functions. So for the default text chords, we will set it to this guy right here because that was sort of our default implementation. So we'll do this, and then I'm just going to reformat this real quick. All right, so we have some default texture coordinates, and our default texture will just be null. So we'll assume there is no texture, which means they're doing a color or something, which is fine. Okay, go back into sprite render. Now we lose that error, and we're going to have more errors, though, inside of where we use this. So let's go and try and solve these one by one. Sprite sheet. So how do we now do this? Well, we can say sprite is that, and then instead we'll say sprite.set texture, this dot texture, and then we'll say sprite.set text chords, text chords. So let's go and remove this, and then we will create these functions. And if you do not want to write getters and setters manually, you can install Lombok, which was mentioned by Mr. Maniac. So Lombok is just a library in Java that basically allows you to declare something like this at getter, and then it basically creates getters and setters automatically, which is nice. I'm fine with typing this out a little bit. It's perfectly cool. We'll go into our sprite and create those real quick. So we will say public void set texture text. This dot texture equals text, and then we will say public void set text chords, and we'll take in an array of vector 2f, and this will be text chords. This dot text chords equals text chords. All right, so we've got those setters real quick, and this was inside sprite sheet. Now we have no errors there, and we have no errors with texture. So let's run this again. We're going to get more errors. Okay, new sprite render. We cannot do this anymore. Let's do this instead. We'll say sprite render obj1 sprite equals new sprite render. And then we will just pass this guy the obj1 sprite. And then inside of here, we'll say obj1 sprite dot set color, and we'll give it one or new vector for f1. If I can type 1001. Okay. You may be like, oh, this is going to make things so much worse too and everything, but don't worry, we won't be doing this feature because we will literally be editing everything from within our level editor. You'll see. It's really cool. Okay. Now we need to do the same thing for obj2. So let's go up here. We'll say sprite render obj2 sprite equals a new sprite render. And then we want to set the texture to that guy. So let's say obj2 sprite dot set sprite, and we want to give it some sprite. So we'll say obj2 sprite. And I'm actually going to change this to render, just that we're clear about the difference. Then we'll say sprite, obj2 sprite equals a new sprite. And then we'll say obj2 sprite dot set texture, asset pool dot get texture, assets slash images slash blend image 2.png. So we're just refactoring right now, making sure our code works with this new system, which it will. And we'll be good. So then we'll just say obj2 sprite render, and now that should be fine as well. Okay, I'm gonna comment this out real quick too. Let's run this again, and we get everything just as it was before. Cool. So we have now sort of factored that stuff out, abstracted it a little bit, made it better. It no longer requires constructors, which is good. Texture should no longer require constructors too. So this is sort of the last thing that we should do. What we're going to do is instead of taking in a file path like that, we'll just say public void init, and then we will copy all this stuff. And let's paste it into here. and we will actually take a string file path in here. This is just so that we can, once again, remove these constructors that take in variables. So texture will no longer take that. Now we're going to get an error for this one too. So let's comment that out again, and then we'll get an error inside of our asset pool. So instead of doing this, what we're going to say is texture is a new texture, texture.init, and then we will give it the resource name. So same functionality, just factored out into a different method. Okay, once again, we get the same thing. This is an image, this is a color. It's all rendering correctly. We're good. Now let's go back to our level editor scene, and let's try and serialize this sprite render for obj2 and obj1 and see what happens. So obj2 sprite render, let's see what happens when we do this. We're going to get an error. Okay, so we get this giant stack, and you're like, what the heck is happening here? And it's just like, okay, we had a stack overflow is actually what happened right here. So why the heck did that happen? Well, if you look in component has a game object. Let's mark this as transient, because what ends up happening is your serializer is going through and it tries to render this game object. Well, game object just so happens to have a list of components. So then it goes and tries to serialize these components. Well, these components just, and then it goes on and on and on. And that's why we get that stack overflow. So marking this as transient means, hey, we have a circular dependency here. Please do not serialize our game object. We purposely made it that way, but we would like to serialize this part ourselves. So if we run this one more time, you'll notice it runs, and let's see what it printed. Look at that. So it just serialized everything without us having to do a thing. Color is 1111. Sprite, it gives us the sprite's path, the texture ID, the width and the height, and the texture chords. This is awesome, guys. If you watch my geometry dash, remember how painful it was to do all that? And now it just literally automatically did it. And we will make this even more powerful too. So just wait. Let's go back into level editor scene real quick. Let's try obj1 sprite, and let's do something interesting. Let's change it from its default. So I'm going to change it to green and move it down here a little bit. Let's see what happens. Well, actually what's going to happen is it's just going to be red anyways because we're doing it right here. But if I take this and we'll just print it out in here, that should not pose too many problems. So we'll create a Gson object in here, and we're just going to get flooded with a bunch of printing messages. And then we will make this obj1 sprite a private variable up here, just for now. And then we'll just remove this just so that we can see and make sure that this is working properly. Okay, so we are going to serialize that every frame, which is slow and stupid, but it doesn't matter. Okay, change the color real quick. Now, if we scroll up, what was the latest color? Look at that. It was whatever we were changing our color to. So not only does this Gson serialize, it can serialize and detect if this sprite render, this color has changed from what we set the default to. Because like I said, it's using reflection, which means that it is dynamically at runtime figuring out what the value is inside this variable and then getting it. Very cool stuff. Very cool. Let's do one more thing. We will try and serialize an entire game object just to see what happens. So I'm going to go up here and copy this Gson object one more time, and we will paste it right up here. And then we'll just say gson.2 or system.out.println gson.2json, and we're going to give it obj1 just to see what happens. So if we serialize this at runtime, what do we get? And let's see if that looks right. So it says name object1 components, and it starts listing off the components, transform scale, z-index. Cool. So this even works with our game objects, just sort of straight off the bat, goes in and it works. Now, the next cool thing about Gson, and this is going to be where we find our first problem, which we will solve in the next tutorial. But let's take a look at it real quick so that we know what we're dealing with. So let's say string serialized equals gson.2json 1. Okay, we're going to serialize that 1. Then we're going to say int 1 equals gson.fromJSON, Then what we're going to give it is just this serialized variable, and we will give it int.class. So the way you deserialize stuff is you say, hey, I want this string to be this class, and then it deserializes it. Then if we system.out.print line 1, I bet you can imagine what this is going to print out. We'll run that, and we get 1. Cool. What does that tell us? It tells us that this just turned it into a string. Then we just said, give us what this string is, and it figured out, hey, this is a 1. Let's do a little bit more of a complex example, right? Okay, let's try a vector to f. So we'll say new vector to f, 1, 1. We'll do 1 and 0.5. Then we'll say vector to f, vec equals a Gson.from JSON, and then we'll give it vector to f.class. That's what we're looking for. Then we'll print it out. Let's see what happens here. Okay, we get 1 and 0.5. This is in exponential notation, so that's 0.5. What does this tell us? This tells us we turned this into a string. Okay, remember, we just turned this into a string. Then we literally just said, hey, use this string to give us this class, and it did it. Let's print out that string just so that we can really reiterate what happened there. So if we print out the string beforehand, you'll notice it said, turn this string into this, and it worked. It did that. That's really cool. But now we want to do our game objects, right? Because this is how we're going to do our game levels. We're going to serialize game objects. So let's try that. Let's see what happens. Say obj2. We'll do 1. And then we want to turn that into it. We'll print it out to make sure that it looks right. So we say system.out.print line serialized. Then we'll say game object obj equals Gson.from JSON, and we're going to give it that serialized again, and we're going to say game object.class. That's what we're trying to cast it to. Now we'll say system.out.println obj.get name. Well, we can't do that. We'll just print out the object, see what happens. But we're going to get this error. What happened here? And let's look here. It's something with our component. Failed to invoke public j.component with no args. Wait a second. It was trying to invoke component. Component is an abstract class. We should never be trying to invoke its constructor. And this is where our problem lies. So because we have this abstract class, we need to do a little bit of extra work to make sure that this can be serialized correctly and then deserialized to the correct type. So we will talk a little bit more about that in the next tutorial, and we will go over how to solve this problem so that when we go to do this whole serialize, deserialize thing, it will work as you would expect it. But this has been an intro to Gson and serialization. I hope you guys enjoyed this, and I hope you can start to see just how powerful this stuff is. Now, we will be going over how to solve this problem in the next tutorial, and I'll see you guys then. Thanks.